Alright, time for another DraftPhysics.com, DebatePhysics.com also. Video presentation. Unfortunately, even people who should agree can't agree. So yes, agreement is just so difficult with people. So David D. Hilster, where we have a common interest in the fact that we believe the universe is simple and mechanical, and therefore it's bumping particles. It's things banging into things, causing effects. There's no mystical forces. There's no wooey stuff. There's no anything that does this without some kind of reason. Nothing can have muscles and do fancy movements and be fancily controlled unless there was some way too complicated a system. So it's basically, he wouldn't, probably won't go along with my simple statement that it's about Sisyphuses and it's about boulders. And so all you really have is forces, all right, in the form of things moving the speed of light when they're not pushing a boulder. Okay, so that's the force mechanism. It's a thing with a mass, okay, in spite of what physics says. The photons have a mass. They cause a transfer of momentum. Newton said pretty much explicitly, force equals momentum. Whatever change, whatever effect you have, the force causes it, and it's always in the form of just a transfer of momentum. So, in a simple argument is there's boulders. And that would be the electrons and the protons, okay? They're the boulders. They get pushed by the force. And that's where the real universe is. Tiny little universe, empty space, electrons, protons, and force. And that's all there is. Everything else is that first. So he would maybe possibly agree with that, but I'm not sure. See, he just has his own pet theories like this expanding Earth crap, and then he has this particles all the way down kind of crap, like there's an infinite another universe underneath this universe and underneath that and underneath, and all that kind of crap. So all that gets in the way of simply understanding that it's just about what we call a force, the stuff moving the speed of light, and the fact that it causes momentum in objects, or the object rejects it and just reflects it, like you're doing right now. A bunch of light is hitting you, you're not getting hotter and hotter. And the fact is that you have to release all of it. All of it goes back. So you're just a reflector. And that's all the matter's doing basically, is absorbing and reflecting. Because most things are at equilibrium with their universe. Nothing gets infinitely hot. Okay. So anyway, so yes, they believe in a particle model. And he's claiming that they're the only people in the whole planet Earth that have ever thought of this idea and blah, blah, blah. And so I just thought it was, wow, come on. I mean, right in front of him, I've been doing this channel, so he knows of my existence. He knows I'm definitely a particle, arguing for a particle theory. And you're just saying, come on. This is something that occurs to human beings now and then. And nobody pays any attention to them, but I mean, it does occur to them. They all independently arrive at a conclusion. Before I ever heard of Lesage gravity, I thought of particle gravity, just like his father did. Because it makes sense. It's a force. It's not some bent geodesic. It's not some bent nothing. It's a something, and it behaves just like wind or water or any kind of paint spray, any kind of photons coming from the sun. It behaves just like any other particle, individual, discrete mechanism, and it obeys the inverse square law. It has exactly the same features, and you're just saying, well, it's going this way instead of that way. That's the only difference, but it's the same idea. How fast you go across a stream will decide how much you're pushed by the stream. How fast you go by a gravitational body will decide how much you're bent by the gravity. It's obviously a constant force in the sense that it goes through things at a constant rate, and you acquire the interaction in units of time, 9.8 meters per 1 second. See, he doesn't pick up on any of these other subjects, 9.8 meters per second squared. He doesn't pick up on the 25 times the fuel to go 5 times as fast stuff, and you're saying, well, why doesn't he figure out how all that's bullshit too? So anyway, I don't want to go into, I mean, there is a history here, so, you know, this is a video that's worth making, I think, just to, you know, because he's making new videos, and it's nice to see that his father's of reasonable health and whatnot and all of that. So, but he has so many of these other, you know, all this crap, you know, tied to his understanding that kind of just breaks the simplicity. This is what you're looking for in the end. You know, it's very simple. The universe is very simple. All right, so let's play some of this and such.
This is a series of videos that tell the story of how my father and I came up with the 4 universal motions in physics. We highly recommend that you watch these videos in order. Enjoy.
I don't even know what that means, but whatever. This is video number 2, and I watched them in order. I don't know exactly what it means. So anyway, so again, they're just going to argue that, you know, that stupid thing they draw is, call it a photon. It's really just a frequency between events. So there's things moving through the space, and they have a distance between them, and that's what they call the wavelength or frequency. Is just the period between those events, and that is the nature of the photon. But he doesn't go into any of the details about how it interacts with the surface or the polarization of the light or any of the stuff that I have gone into. So it's like they've got a very undeveloped theory. You could almost argue like Lesage didn't deal with drag. It's a real thing. They didn't, you know, they needed to deal with it, and they didn't deal with it, and that's just the truth. Don't really need this. So I don't know what 4 universal motions are. There's just one universal motion. There's Sisyphus, and there's 3 things that can happen, right? The Sisyphus can bounce off the boulder. The Sisyphus can stick to it and push it, and now move much slower. You know, pushing the big heavy boulder means the Sisyphus can't go the speed of light anymore. Or, as I've discovered, if you simply transition, that is, you have 2 kinds of Sisyphuses, electron Sisyphuses and proton Sisyphuses, and you just have them reverse their identity when they go through an electron. Say a red one hits a blue one, it would become a red one. No, it become a blue one. And vice versa. That will create charge, and that'll make electrons repel each other, and it'll make protons and electrons attract each other perfectly duplicating Maxwell's equations, Maxwell's predictions for the behavior of charges. You can perfectly do it with just 3 interactions: pushing, bouncing, and converting.
Of all the human beings that have lived during the last 400 years.
So it's again, 400 years is the key time, right? So this is the Leibnizian theory. So at the same time they're turning particle theories into wave theories, they're also converting energy into some preposterous nonsense where light things going fast are somehow have more of something besides just having a difference that can make a difference. Yes, there's a difference going fast. Going fast means you can break things, but it doesn't mean you have more energy.
Why did my dad come up with a solution to one of the most famous problems in physics?
Because he did the same thing I did in high school, which is you look at that silly drawing of a photon and you say, what the fuck is that? How am I supposed to make any sense of that? How does it know how to do all of this crap? How long is it? What is it? How does it exactly interact with the surface? How big is it? Is it actually hitting 1 electron? That big giant thing? I mean, the frequency alone is 500 atoms long, but the polarization is also that big. So something 500 atoms big is somehow going to interact with 1 single electron? Yeah, my brain said, oh, bullshit it is. That doesn't work. And it automatically converted it into events. And then I just had to spend the next, you know, all these other years just saying, well, they're saying it does this, and it has to do this, and it has to. So I kept trying to put their rules on it and make it work. And it wasn't until I said, oh, screw, all their rules are garbage. Until you have that moment where you say, I'm just going to start over from the very beginning. I'm going to assume all their silly statements about their interpretations of experiments is all bullshit. and start over from scratch. Then you have the freedom to think rationally, because you're not injecting a bit of nonsense they claim but they never proved.
Today, we will tell you why.
So 2 intros, 4 intros, 25 intros. That sounds very impressive. Big crash.
So, Dad, that's the big question. I would imagine that's one of the first things you thought of once you realized you solved this problem. You pondered.
So again, you didn't really solve anything. Particle arguments were made. Newton even accepted for a while the idea that gravity might be a particle force. So it certainly was certainly conceivable to a human being to recognize that I'm going to have a theory of things interacting with things. I'm not going to have a theory of nothings interacting with somethings. Nothings interacting with somethings is something other than reasonable.
On what I told you have done, but you took some time mulling that in your head. And when was the first time you really started thinking, why me?
First, I had to figure out that what you were saying was true, that there was a problem called wave-particle duality, and I went and...
Yeah, so it's part of it, because, yeah, I didn't realize exactly how bizarre their theory was, until much later. So I knew photons weren't this squiggly thing. But, the fact that they had this double slit experiment and they were claiming that the photon goes through both slits and it interferes with itself and it's just like a wave. Well, I knew that once I heard that silly story. I said, oh, well, I know this needs to be fixed because that can't be the truth. That's just too silly.
Looked at that for a while.
And so right off the bat, you sit there and say, okay, well, what do I see? I see surfaces. And so I was always concentrating on the fact that, what's the only thing in the experiment? Well, there's a surface over here and a surface over here. That's what's in the experiment. So it seemed clear that was the thing causing the problem. And so then the real issue was to figure out that it's only the photons that go by the surface that are actually creating fringes. So the only fringe light is a small percentage of the total light. And if you make the slit really, really small, well, then obviously the surfaces become, all the photons go near the surface. So a tiny aperture, none of the photons survive. They all go by a surface.
While I went on the internet and read what I could, and finally concluded after maybe several days that, okay, maybe the light solution does solve that problem. I immediately followed it with the question of myself, well, why me? I'm an engineer. I'm not a scientist. And
so to say you're an engineer and not a scientist doesn't make much sense in my opinion. So I don't even understand that difference. Obviously, engineers draw conclusions based on experiments. They do all the time where, oh, I just got electrocuted. Why'd that happen? Or hammer on nail, thumb in the way, all kinds of experiments are conducted. So, but whatever.
Why should I solve some great...
Yeah, so that's the thing, though. It's, you say why. Now, for me, I can understand why. You see, he looks like kind of a conformist type person. And I was never a conformist type person. I didn't think anything was right. Okay, the whole structure of society was wrong. All kinds of nature itself is a pile of suck, a bunch of torture and agony for, ew. Deserve has nothing to do with it, clearly. Lucky, that's it. Absolutely disgusting. So yeah, everything was broken. And physics is just one of the broken things. And the real thing that makes it compelling is just the fact that their ego is so big, and their arrogance, and their we have the truth, and their theory is just another religion. And pretending they're above religion. I guess that's the part that's so offensive. The scientists are all pretending they're atheist, and they're looking at the reality, and they're looking at the hard truth. And here they are, making up wooey stories about how they're going to go through a wormhole, and have sex in 74 dimensions. Bullshit they are.
Science problem, and almost out of the clear blue, because I didn't even know it was a problem. What did I do? to deserve this honor.
Well, it's easy to see it's a problem. I'm just saying, like I said, I have the clear vision of the chalkboard and the silly drawing of the photon, and my brain just saying, "Oh, fuck you! What are you doing? This isn't. You know, why are you drawing that piece of shit and telling me that's a photon?"
Or maybe it was a curse. I'm not sure.
Well, it's interesting because even though it don't
see the context for me, I've mentioned before, was the fact that in the very same, like 2 days later or whatever, we're making little cloud chambers, and I'm watching radioactivity shoot little balls of shit, you know, and it just seems, how can you be talking about this silly photon idea when you can see that this is straight line crap? It's not, you know, this isn't about wooey crap. It's about, you know, lines of force, straight lines of it.
only took you a couple of days to figure out what you had done. You didn't come to me right away. You spent the next 2 weeks thinking, why me, why me? Did you come to the conclusion?
So it's kind of strange to do the why me thing when their theory is so incomplete, right? So, I mean, it's hard to have, see, I have confidence now because I've got 10 years to build that confidence where everything I did ended up improving the theory. It got just better and better and better. I mean, you know, being able to duplicate charge was a huge one. So you just, you know, once you can do that, you can say, well, photons are nothing compared to, you know, explaining why electrons repel and protons and electrons attract. I mean, getting that one is a real confidence booster.
Or get any answers to that, or you just said, the heck with it, I'm just going to go back to Dave?
Initially, no. I really think with discussions with you, it was you who came up with the answer based on knowing what some of my background was. And
well, the answer is the more you investigate their theory, the more you hear and find out it's all lies. So they say they do an electron double slit experiment. There's no slits. They're shooting electrons at a solid crystal. I mean, it's just, once you figure out that all of their interpretations are based on bullshit, that they can't draw the actual double slit pattern, they can't draw the single slit pattern accurately ever. They just do some sloppy lines and say, there's the pattern, it's on off, blah, blah, blah. And they don't pay any attention to the details, and it's the details that prove it's not a wave, because it's doing something very different than what waves would do.
I wasn't tying this model to that background.
What we're going to do is we're going to take a look at the document that you had sent me before the time we had in the previous video, the aha moment where I saw that you had solved this, and even though you didn't know it yourself, you had sent me a white paper. And I went back 10 years in Gmail and I found that white paper. And it's interesting because the first white paper you sent me didn't have those round circles representing particles.
It's kind of funny they wouldn't do that on the phone or something. They'd send a white paper, but whatever. You know, long distance calling was cheap, you know, for quite a while now. I mean, you have to go back 20 years where you really got screwed.
For light. So here it is, the famous white paper that you had sent me, and it says at the top, a particle theory of light, exclamation point. And gravity too, which is kind of interesting since now we believe it's the same particle. Actually, it's just how it moves. If you look,
so they're not really saying the rest of it. The other punchline is they think there's some other particle that goes twice the speed of light, or the speed of light squared, that makes those little force bits move in funny ways. So I mean, they ruin their own theory by creating some sub-mechanism that's controlling the syphicuses, and the syphicuses are just moving in straight lines. You know, they can't do anything else. They push in straight lines, they fly in straight lines, they can't do anything else.
look at the bottom part of it. It says string of particles. A string of particles could give both amplitude and frequency. Figure 1 shows a...
So the amplitude part is useless. The amplitude is always about the number of photons. There's no amplitude in a photon itself. So this is a big mistake he's making, that a single photon can be a big photon or a small photon. No, they're all exactly the same. So that's a big mistake. They don't even have to be exactly the same, right? So the whole point is that you see a pattern because the frequency is going in phase or going out of phase. So the phase isn't perfect, like dot 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 is perfect. It's going to be a little bit off, a little bit off. And so, you know, the frequency isn't that explicit. And you'll still see a photon. So it's more like, you know, this is completely out of phase. This is completely in phase. And that the reality is it can be pretty fudgy.
String of dots with varied spacing. Each dot is a particle. It is matched with a sine wave. Particles are closer together when the sine wave is at a maximum, and they are further apart.
So he's still using the sine wave for no reason. There's no actual sine wave that you can indicate hits a surface. All you do is either create electricity or no electricity. There's no sine wave involved. It doesn't create an electrical sine wave. It just creates either an electric impulse or no electrical impulse, charge or no charge, a change in the charge or no change in the charge. It moves an electron or it doesn't move an electron. There's no need for any sine wave duplication. You don't need to duplicate a sine wave. So it's really just, yeah, I shall draw it, the photon. So my argument is that, okay, if you're going to be honest, you got to draw a photon, something like this. So let's just say it has 3 elements. So physics won't tell you that. They won't tell you how many elements a photon has. They'll just tell you it's some sort of something. So many bumps. Who knows how many bumps? And the idea is they'd all be flying in parallel to each other in a straight line. So this is their frequency, obviously. And they also have a polarization, okay. And those are the key features of the thing. So there's no sine wave in there. There's 10 photons, 10 little bits here, and 5 little bits here, and 3 little bits. No. It's not gradually getting stronger and gradually getting weaker, any of that crap. It's completely unnecessary. There's no experiment that demonstrates that photons are variable. The whole Einstein point was it's clumpy. You get it in little clumps, and you can't get a half a clump. You either get a clump or you get no clump. That's it. So they don't need to do this to the particle model. They just need to recognize that there's 2 features, you know, polarization and frequency.
Apart when the sine wave is at a minimum. The time of the wavelength is from one peak to the next. The inverse of the time is the frequency. So you did that, and then you said figure 1 is not yet available. And I think what probably happened was either you didn't make it.
So I guess I'll draw that. I mean, it's just to be fair to what they're arguing is, you know, because his own drawings are kind of hit and miss in terms of being explicit enough, I suppose, to what they're actually arguing takes place. So what they're essentially saying is that you have a couple of particles, then you have 3 particles, and then you have 5 particles, and then you have 3 particles, and then you have 2, and then you have 1 again. So they're reduplicating this kind of crap. And it's completely unnecessary to turn photons into DNA molecules or anything like that. It doesn't serve a purpose, isn't useful, isn't necessary.
You sent it to me, or it wasn't included at the time.
No,
So-
I remember writing the note, and my intent was to do a figure. Then inadvertently, sometime later, I sent it to you without ever going back, doing what I wanted to do. So you ended up with this stuff.
Yes, a completely unnecessary part of the story. So, oh, I forgot the figure. That's all you had to say. Yes, and too bad.
Document without a figure.
I went and I found another paper later on that you had sent called, I think, the EM particle. Let's see here. The EM particle. And there it is. And what's really, really interesting is that what we had thought many years later, well,
See, you can see from that diagram that it's got these, you know, variability in the frequency. It doesn't really make any sense. That can't be what a photon is. So, wrong. A photon is created when it hits the surface, right? The stuff in the atmosphere. So the whole thing that the double slit proves is that you take 2 surfaces, or 4 surfaces, and what you can do is break photons at those surfaces. So you're just sending the pieces at a distance, And the fact is, you'll either make or not make a photon on the surface. So it's really not about a photon being something in air that flies through air and hits a surface. A photon is also energy that comes from different locations that hits at the right pattern, the right frequency. And so there's no photon per se heading for the object. It's just made when it hits the surface. A photon is just a pattern hitting a surface. Yeah, that's pretty much all you need to say.
We were writing our book was a totally different diagram, which we're going to look at. But if you look at this, it's exactly what you had described. You have a bunch of particles, and they vary in their spacing. So the red dots represent the points in the sinusoidal wave that would cross a line if you're doing this just mathematically.
Right, so it doesn't make much sense, right? So he's arguing there's some sort of this thing is happening. It doesn't make, there's no sense to make out of that. And it's really just about this frequency is the important part. And the frequency is between where there's a bunch of particles, then there's very few particles, then there's a bunch of them again, very few. That's how a radio wave is transmitted, is that it just compresses a whole hunk. Well, it's actually in this shape, right? This shape. Obviously, it goes up the antenna, right? So this part of the antenna is producing the pattern first, and then the top part produces it a little bit later. So the whole compression is traveling through space like this. Okay, that's the photon. The frequency is this bend in it. Okay, and the polarization obviously is this width. That's why there's antenna polarization.
Physically. If you buy our book, the Principia Mathematica 2, this is not what you're going to see there. We somehow had a different diagram, and because I didn't go back and look at this.
So this obviously has at least the right consistent frequency, and you're saying there's a something, there's nothing, there's something, there's nothing, there's something, there's nothing, so that part makes sense. But obviously for things like radio waves, it means that there's a whole bunch of particles here, a whole bunch of particles here, a whole bunch of particles here, and what they're going to do when they hit a surface is they're going to push electrons. Because of this angle, they're going to push electrons.
I just assumed, okay, it wasn't included, and I don't know where this other diagram came from. So let's take a look at.
So I guess that's part of this whole story, is recognizing that it's all the same thing, a frequency, but you can't just say radio is the same thing as, because very different devices are producing it, right? There's no antenna producing visible photons. No antenna you can see. There's obviously an antenna in the sense that there's actually the materials that are going to produce photons, reflect photons, all have to do with atoms in some sort of arrangement. And so those colors are all being caused by chemistry. Okay, so you have a certain chemical with a certain arrangement of its electrons and protons, and that's the pattern it's going to produce. So it's going to absorb some colors, reflect other colors. So it's a lot more nuanced for photons than it is for radio waves.
Did later on, without ever.
And the other thing just really important is just to recognize how we're always at equilibrium with this force, right? The force comes in, it's got to reflect off of me. I can't absorb it. Technically, I can't absorb it and keep it. I can absorb it for a little tiny bit of time and then release it as infrared or some other unseen color of photon. Okay, but I'm not going to absorb it in reality.
Seeing this, so I didn't see the above diagram or remember it when I was creating this one. I didn't go back.
So they have all these different diagrams, and you're saying, well, which one is your real story? So this is more like what radio waves would be, but you just ignore the sine wave they put on top of it. It has no use. So if you just recognize that this is what a radio antenna is doing, all right, it's causing a compression, and you have to slant those lines, because you have to recognize that the antenna, the electricity travels up and down it at the speed of light. So it's producing energy at the bottom first, and then later producing energy at the top. So the compression is in this kind of shape. That's the frequency, is in the shape of the compression you're creating in the field.
to the white paper, we were writing the book many years later. Lo and behold, I did sort of the same thing. And the difference here too is I put little arrows on all the particles, meaning they're all moving together like waves of bombers. But what's curious about all of this,
so this is a really easy part to understand. What causes that compression is just electrons moving on the surface. So every time an electron moves, it interacts with one little tiny piece of a photon, right? The photon is the composite object, and the electron can only create one piece of that composite, an individual electron. So it pushes out. When it pushes out, you can understand that if 2 bits are coming in with this distance and it pushes out, then the 2 bits are going to leave as reflections at that distance. So that's why all we're really doing is converting low energy photons, that is high frequency, big frequency objects, into small frequency objects, and vice versa. That's what we do. So the light you absorbed, the colors that were absorbed, are really just being reflected as infrared, because those electrons were going this way. So it's just red shift and blue shift. Blue shift means you're increasing the frequency, making visible photons. Red shifting means you're increasing the increasing the frequency and likely making an invisible photon, a non-visible photon. See, none of that sounds right? Non-visible. You're just saying you can't see it with your eye. You're not saying it's not a photon.
is this. Now, somehow in our book and in our journey, we thought that this was an original diagram. Now, maybe you wrote this.
So he has numbers here below, so there would be, that's where he's recreating this wave thing. So there's 5 here, 4, 3, 2, 1, trying to recreate amplitude that you don't need. The only amplitude photons have is their number. They don't have an individual amplitude.
Showed this to me, sent this to me at a different time. I have not found it yet, but the idea is they're all spaced the same and they have these particles, and there's 1 particle, 2, 4, 5, 4, 2, 1. You see those different numbers, and I expanded it visually, and that's in the book as well. So this is the kind of expansion to make it more visual of what's going on. So this is really curious. I don't know how we digressed from what you had already done, which is this diagram, which was the diagram you sent me originally before even the talk you gave, and I understood what was going on, to how we got to this. And then, of course, eventually then I looked at it and says, no, it's going to be a lot messier than what that is. And so I got more what we call a more realistic, messy way. So
I don't even understand that. So, there's just no way of even understanding this clumpy stuff, whatever that is there in this era. I mean, what the hell is all that crap? Nothing simple there. That looks like a mess. Photons don't interact with each other. They don't interact with each other. The clear rule is that photons don't interact. They're straight line vectors. Say if they directly hit each other, well, then they would just bounce off of each other, and you'd still have a piece going that way and a piece going this way, so you wouldn't be able to tell the difference. If they missed each other, they hit each other, the universe would look exactly the same. So obviously there's no capacity for them to interact in any way you would see the difference in the universe. The universe will look the same if they interact or don't interact.
you don't know either where this other diagram came from, that one, right?
Well, I feel like the top one is something that I might have done.
So what you're saying is you admit that the top one probably was one of your diagrams.
That top one,
Yeah.
When I developed those numbers, I was actually looking at a sine wave and coming, let's say, close to the value, but using integer numbers.
Yeah, and there's also equal spacing, which we're going to talk about in a little bit. We'll get back to that. This is what you produced, and we got to the kind of more messy wave. In fact, here is even a kind of an animation, even though these are kind of perfect in the sense you see them kind of all in long lines. But this gives you an idea of what kind of looks like.
No, it doesn't give me any idea at all. You keep switching from one diagram that's all kind of showing us a sine wave to now another diagram that shows compressions moving at different speeds. somehow that's possible. You can't move at different speeds. There can't be bits going one speed and bits going some other speed. They all have to go the speed of light, so none of that really makes any sense, frankly.
These are moving through space. So this is kind of the model we have. But if we look back in time, we're trying to figure out why Robert D. Hilster got it, and why didn't Newton or Maxwell or Einstein? Newton thought about a particle model for light, correct?
Yes, he did.
And he had wrote the...
yes, look, the whole word corpuscular comes from Newton, describing the fact that it's clumpy. All right, so that's where Feynman sort of got that from. Also, it's clumpy.
Optics treatise for light, and in that he had Newton's corpuscle theory for light. Why don't you explain that a little bit?
What he has are particles, but they're different sizes. I think he was not trying to describe the frequency in terms of a literal wavelength between particles. He was
yes, obviously you can use the size of the particles as a way of distinguishing a frequency, in the sense that little things can be close together, big things can't be. Their center of mass couldn't be, so they would be at a higher frequency. So yes, it's a good, so it's an okay guess. I mean, Faraday had all kinds of gear work, descriptions of how energy is absorbed by a material, and it was all a bunch of gears and pulleys and all kinds of stuff that can't be the truth.
Trying to describe it in terms of the size of the particle being related to frequency. I think ultimately that was one suggestion he made, but I don't think he stuck with that.
So let's go forward. This is just our famous, you and I's least favorite picture of what they call an electromagnetic wave. So tell us about this diagram.
I forget who it was who did the experiment that showed that a magnetic field could produce electricity and
well, Ampere was the big one, but anyway, he spent 10 years trying to find radio waves, essentially, and he found them. But anyway, they never draw this accurately either. Okay, the magnetic field is like 1,000 or 1,000,000 times weaker than the electrical part, so the whole thing is just a pile of crap. But there's absolutely no need for all of this fancy crap, because it's really just a frequency and a polarization. That's all a photon can produce as phenomenon, is a frequency and a polarization. And we don't even know which one we're detecting. Frankly, when we're detecting a frequency, we could be detecting the polarization because it's proportional to the frequency. So, science can claim, oh yeah, we're tuning into a frequency. Well, you might be just tuning into a polarization.
Electricity could produce a magnetic field. In some sense, they were perpendicular. And I often use my hands to describe that. My finger is a current. The magnetic field is a circular path around that wire. And so
there's no circular path. That's just the equidistant line that you can draw around a magnet. But the force is actually just straight lines. So an electron is radiating electron force in straight lines, and proton is radiating proton force in straight lines. And it's just about breaking the radiant lines. The field lines are just an abstraction. That just has to do with how strong the force is and whether you're balanced against a positive and a negative. So you put a positive charge in, you get one answer. You put a negative charge in, you get a different answer. So it doesn't, it isn't the real part. The real part is the lines of force, not the field lines. Field lines are an abstraction. Lines of force are the reality. Magnets are reflecting straight line vectors of force, and they have a pattern. Red, blue, whatever the pattern is.
That circular path represented by a diameter of the circle there are perpendicular. They broke it into two separate fields, an electric field and a magnetic field. And every time I look at that drawing, I keep asking myself the question, what's causing them to oscillate up and down?
There you go. That's the big, yes, the giant gorilla thing in, the elephant in the room. Obviously this is a complex motion. How can the whole universe be pushing on it this way and pushing on it that way to make it do this wiggly thing? It doesn't make any sense. Nonsense. It's what that is. It's nonsense.
They start out at zero, go up to a peak, back down to zero, down to a lower. You can draw that, but it's got to come from somewhere.
So again, the idea that the photon has the actual character of going of an amplitude, an individual photon has an amplitude, is just nonsense. They don't. They're all just the same thing, a certain quanta, as Einstein stated, of bits of energy, and that's it. Energy quanta, you want to call it light quanta, it's little bits, and that's all it is. And they're all the same, and all you're changing is how often they hit, how frequently they hit. So I throw 3 baseballs really quickly at something, I'm likely to tip it over. I throw the baseballs today, I throw one and it wobbles, and I throw one tomorrow and it wobbles, and I throw one the next day and it just wobbles. I'm not going to tip it over. So frequency matters in terms of tipping electrons. And
what's the source?
But it's all the same amount. It's all just baseballs. And all you're doing is changing how quickly they interact with something.
For that wavelength that makes sense.
This is the epitome of where physics is today. There's just zero physicality. It's all.
So all of it, yes. Every subject, there's no real hard physical evidence. They never repeated the Eddington experiment from space, never proved that photons are twice as bent by gravity. Absolute nonsense, blah, 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 blah. Photons, this subject, double slit experiment, they can't even show you the accurate patterns and draw their math and duplicate the mathematical relationship unless they draw the point sources being the surfaces. The surfaces are the cause of the effect. They measure the surface distance from each other. They're basically conceding, yes, it's this point source and this point source, and I'm going to draw vector lines from those 2 points. I don't draw it from the middle of the wave. I draw it from the edge of the surface. So obviously their own math concedes. The only rational explanation is that this is all a surface phenomenon. The surfaces are causing the effect. And you need 2 surfaces because you need 2 sources. If you break the photons and just throw them, well, there's no chance you're going to make a new photon out of those pieces. But if you have a second source throwing pieces, now you can make a new photon. You can rebuild a photon.
All mathematics, it's all diagrams. This is math. Like you said, what's causing this? What is it? What's a magnetic field? These things are magical things that people talk about, an electric field. This is a mathematical representation of somehow the forces involved.
Okay, mathematical representations are okay. Frequency is a real thing. Okay, now this amplitude thing isn't, the sine wave isn't. Alright, but the fact that you can have a number of photons, okay, just like you can have a certain amount of gravity, 9.8 meters per second of increase in your velocity, well, that could just represent 9.8 hits by pieces of paint. I could just say you get hit by 9.8 pieces of paint, okay, per second in this location. And if you're closer to the sprayer, it's 15.9, and if you're further away from the sprayer, it's 4.2. But at this location, this is how much you get hit with. And so, yeah, math isn't all bad. It's a formalization. It's a simplification of a process. And you're saying, what are the elemental, essential components of the process? So there's nothing wrong technically with the math. It just has to do with what they're calling the feature. They're saying it's an electric field. Well, no, they're just saying that's the frequency. That kind of thing. There's no need to... The math is really just about these simple dynamics of the speed of light and a frequency and a polarization. That's what goes into the math.
And zero indication of what this all could mean. it's a useless diagram. It really is, because
so I wouldn't go that far. The math isn't useless because it's formalizing the simple components, but just recognize there is no wave in Maxwell's equations. There's no wave function in his equations. It's just simple dynamics about stating a frequency and a velocity. Those are the essential components.
I get the same reaction from Maxwell's equation because those equations are so abstract. I don't know how to.
See, they're not that abstract if you just recognize that they're just saying this is a feature, okay, and you're just recognizing that it has a function. But the feature is just frequency in the end for photons.
Relate the terminology. Yeah, the B is the magnetic field and the E is the electric field.
Even before Einstein, there were people looking at ether. This is actually a sound wave in air, a model of that. But if you watch any,
I don't know, it doesn't look right, because you have particles going this way and particles going that way, so I don't know. They're actually moving, they're not
you'll notice that it's only going back.
But whatever, whatever. It's not a very good simulation, but obviously ether is nonsense. That would be gluey. You know, that would be impossible to get anything to move in, and you can't. The geometry of ether is impossible. So any ether theory requires there to be something everywhere, and you can't draw straight lines in an infinite number of, you know, in any direction on that checkerboard. Checkerboards just don't work. You know, there's lines you just can't draw because you're not going to go through the center of anything.
Back and forth. And so the proposal for the 18th and 19th century, specifically the 19th century, everybody was looking for ether. They said light has to be a wave. It has to be a wave through some medium. We're going to call it ether.
I don't know if everybody said it. It's just that there weren't enough people who would be willing to say, no, let's say there were. It didn't matter. It was sort of science like everything else. They found democracy to be a kind of a nice idea, and so it just became what the majority believes became the establishment, and anything that's anti-establishment was censored. So it's just like the Inquisition censoring Galileo. It's like once you have a gang and a majority, they are defensive of their territory, and they will try to shut up and annihilate anybody who challenges the authenticity or credibility of what they're arguing. So it became a religion, and the religion had a dogma, and if you were to argue against their dogma, they would jihad you, and it still exists today.
And they searched and searched and searched for it. Very famous Michelson-Morley experiment to try to find us moving through this ether. For, of course, no one ever explains.
And you can't even, you know, all of these experiments, again, so the Michelson-Morley is another example of where they don't even understand beam splitters. You can't create two equal beams with a beam splitter. It's impossible to do because there's a functional reason why half the light's reflecting off the mirror, and a functional reason. So just a plain piece of glass will create 30% of the light will reflect off of it at the right angle. So, you know, you don't even need to half silver it. You don't need even the mirror part. Just the angle that the light is hitting the glass will create half the light reflecting. So, I mean, the whole thing is very misunderstood by physics. So all I have to do is blow some moisture onto the glass, and I create a bunch of double slit experiments, essentially. I create a bunch of surfaces that the photons have to go next to, and they break and split and fringe. So clearly in those experiments, you're not creating two equal beams of light, because one beam of light is spreading through the whole experiment, and the other beam of light only spreads in the last part of the experiment. So they don't even understand the mechanics of their own experimental apparatus. Again, I just had to make an argument about springs that nobody else has made, that springs aren't as efficient at pushing light things as they are at pushing heavy things. It's just an absolute observable fact, and not chronicled in physics. They don't pay any attention to what is a really important fact. If you're going to do experiments with springs in them, you really need to be aware of that fact.
Why this ether would stay in one place, what does that even mean? Why would particles sit around and kind of like they do in the ocean. Well, they sit in the ocean or in the air because we have gravity pushing them down, but that's another story. But this is the ether kind of idea or model. But then Einstein...
All right, just to be technical, right, water sticks to itself without air pressure. So it's a medium. And you push on one water molecule, it pushes on all the others. So it will transmit energy through the medium.
Einstein came along with his photoelectric effect and said, no, light's a particle. You have these incoming photons, and that ejects these electrons. What I just get a kick out of is, look at the diagram, whoever made this, of the photon, Dad. Look at that.
So again, they ruined a lot of this conversation because there's two effects. The the fact that you can create electricity, and the fact that you can actually eject electrons. So there's two photoelectric effects. One of them is just creating electricity. One of them is breaking the surface and sort of destroying it, having the electrons fly off, creating ions. So there's two effects. And it really just has to do with how much energy you hit the surface with. So you can gain plenty of electricity at lower frequencies, but you can't eject electrons at lower frequencies. You can't break the material. You can't ionize it. So there's ionizing radiation that just say everything blue and above is ionizing, and everything below is capable of creating motion in electrons, but it doesn't eject electrons. So we're just back to the tipping point argument. So you can tip it over if the little balls hit quickly. You can tip it over. The little balls have distance between them, then the surface will rebound and compensate, and it won't tip over. So high frequency tip over the thing, low frequency won't tip over the thing, but there's not more energy. I mean, these, frankly, these are all good arguments. I made these arguments to David 10 years ago, and the fact is he should incorporate some of these arguments in his own understanding, frankly. Yeah, because they're really good arguments.
It's it's this kind of oval, and it's got squiggly lines. It's a particle and it's a wave. Mainstream science and physics says light is a particle and is a wave. Again, what is that? But when I saw you do your famous moving fists together, I realized light is a frequency. It's a physical thing, and the only way to get frequency is to have more than one of them coming at you.
There you go.
And so the idea that there is a special particle that you would call a photon is not needed. You can have sun.
Right, well, you're going to call it a photon because it actually accomplishes the task of creating electricity. And if it doesn't accomplish the task, then it's not a photon. It's just some sort of noise. So the fact that there is a dependency on the pattern being coherent to some rules to be a photon.
Out there, if the suns were all traveling together with a frequency like bombers, that's a lumenic wave, just as you have described, and that's why in our four motion.
So why do they do this? Why do they say wave is stupid, and then they sit there and call something a lumenic wave? Why would you bother? Why keep waving something you don't need a wave to describe? It is all straight line vectors. There's no waves. Even the things we call waves aren't really waves. It's vectors. It's vectors of force. Sound is vectors of force. There's actual molecules being pushed in directions, okay? And they're not waving in directions. They're being pushed in directions. And the same is true for water molecules. Individual water molecules are stuck in positions where they're in pressure, and there's only one way to go because there's only one way that's lower pressure.
If you go to fourmotions.org, that's why we call these universal motions, because it doesn't matter what it is, you have to have more than one. So the idea of a photon makes no sense. So one of the answers to the question why...
All right, so there's no reason to throw out the word photon. They're just recognizing that it's a composite object. Photons, like a neutron, is a proton and an electron. A photon is made out of 3 or 4 discrete bits at a frequency.
You is that you spend a lot of time in telecommunications going from analog to digital, taking sound waves that were...
So this doesn't even make any sense, right? We know a digital pulse cannot have these longer bits and then this little shorter bit and all that. This doesn't even coherent. This isn't a translation of the sine wave into digital. The two signals aren't the same signal, so shit, it's just nonsense. I mean, they should have at least a digital pulse that has the recognition that you have a short pulse. See, and then you have this longer thing, and then you have this little one here that would be, why would that even exist? So, yeah, this is just nonsense. Gibberish. Crap.
Analog in converting them into digital pulses. The pulse code modulation basically breaks, it samples the sound wave in small increments, takes the amplitude of that, changes it into a digital pulse.
So that's all this is amplitude. So you're just saying that the number of photons is increasing, decreasing. So of course you can do that in a signal. It can have a lot of compression, a little compression, a lot of compression, but it's not a sine wave.
There's different ways to do it. It's not a straightforward thing, but that's not important here. And then it sends those pulses over a wire, and on the other side it decodes them, and then you can recreate the sound wave. Well, the second and third lines I added there, which is the Bob's light, which is the idea of that one diagram which we haven't found, but you created at some point, which is basically, you know, evenly spaced particles with the number of particles at that point. And then below it is what I would say is a luminic wave, which actually took us almost 10 years to come up with even that terminology. But this is, the bottom one is
Again, single photons don't have an amplitude, so it's just wrong. The number of photons, that's what you can increase. I can get brighter and I can get dimmer. So I can change the number of photons, but I can't change what the individual photons are made out of. They're always made out of the same thing.
Father's luminic wave model of light, which are basically particles moving all together at the same speed, and they have amplitude by how many particles are there, they have frequency by how far apart they are. That way you can recreate any type of waveform.
And there's no reason to turn photons into a waveform. So again, he's just defeating his whole particle theory by saying it needs to have a wave function. It doesn't need to have a wave function. It's completely superfluous. Alright, let's finish this up and such.
So we get to the question, why Bob P. Hilster? Why did he come up with a solution to the wave-particle duality? The pulse code modulation is in my dad's brain. He was working on the particle model for gravity for 10 years and decided to try, how could I make light waves with particles? Put those two together, makes whole...
So here's just, the simple explanation for gravity. That was, again, the elephant in the room, is the fact that the Earth is molten inside. So, it really can't be explained as turbulence because of the moon or some sort of nonsense. You can't sit there and say the heat happened 4 billion years ago and somehow there's a perfect thermos, a perfect insulator, and all the heat can't get out. None of that crap makes any sense. So the heat is something that has to be constantly refueled. And that's your explanation for gravity, is that big things are going to be molten in the center because that's the evidence of the force that doesn't get to you. Because it's busy melting the Earth. So it can't get to you, so it can't push you back up. That's why you fall.
A whole lot of sense why he did it. So the truth is, one in billions in the last 400 years had those two things. How many people were working so intimately with telecommunications?
So again, it's just kind of ironic that, like I said, I mean, my whole introduction to the Hilster was the fact that I had a particle model. So, I mean, it wasn't like this is the only person that, did any research or did any looking into And the fact is, he just doesn't like this model because it's not his model. It's not turtles all the way down or some other kind of bullshit. It's not got infinities in it. It doesn't have anything in the universe moving faster than the speed of light. So it's breaking the rules he wants to break. And so therefore he just ignored my existence, which is his prerogative, but I'm just saying it's bullshit. I had a better theory than him then, and that's the real problem. My theory's better. And it's much better now.
And reproducing sound. There are people who do that, but were they also working on trying to give physicality to fields like a gravitic field, and spent a lot of time on that? No, probably about anybody in the last 400 years of the billions of people. My father.
So obviously there's two pretty close. I mean, the irony is I have the same birthday as the Hilster. We're the same age. So it is kind of funny. Yeah, it's not all that, miraculous an event. Somebody who actually thinks about it and says it can't be. Now the trick is, Bob was retired, so he had time to think about this. I was broken and dysfunctional, so I had time to work on it. And that's the key thing, is to have the freedom to actually spend hours drawing pictures and trying to make it make sense. And that's what it took. I mean, I have just notebook paper, page after page after page of just trying to draw function, to make something work, to find something that worked. Let's put it that way.
Was the one who said light is waves of particles. And there you go. That's the answer. It's the definite answer. And so if any of you get this on Jeopardy, you know what to say, right? Does that make sense? The intense study of a gravitic field using particles, then trying to go to light and having this piece.
So again, I didn't really bother with gravity to start with, frankly. Photons were the interesting subject, so I have to say I started with photons and then went on to gravity. Started with photons, and once you know that photons are real discrete bits, then you know, well, gravity's the same crap. We can't see a lot of photonic energy. We can't see it without a detector, and they're all our detectors are frequency dependent. We can't just see bits of force. We have to see bits of force that have a pattern. They have to be doing the magnet thing, or they have to be doing the electric thing, or they have to be doing something we can see.
See them in your head.
It's a logical connection that you can make there. What I have somewhat of a difficulty is remembering the explicit time when I made the connection and would have.
Well, see, it's not real one thing, right? It's each little piece. You have a bunch of little eurekas, that add up to the big eureka. So you don't know when. Well, I have 10 things that I got to work. Is 10 the magic number, and now I have a theory that's viable? So that's the part where you don't know whether you've got the whole ball, the whole thing. And there's always these outliers, like drag, some argument that could be made that breaks everything. And so, until, you solve all the problems, that's the irritating part, is that you have to do everything. You have to perfect it. And obviously, who has that much time? Yeah, nobody.
Said to myself, wow, I just made this.
I mean, the challenge is you realize that your theory doesn't have to be perfect because their theory isn't perfect. And so the idea is that, oh, I have enough proof that this is more rational than their theory. That's the first step.
The connection. That kind
more consistent with the evidence. So again, in this simple argument about mv squared, we know that it was just invented as a statement, a religious statement, that there was no proof of this living force. There was no experimental evidence of this living force. And that if you just look through the history, it was just all a bunch of deceptions. I mean, people got confused because they dented clay with round objects, and they didn't realize that that's not a fair experiment. So you know, there's really nothing. There's just no evidence to support that theory. So you're saying, well, what do I need to defeat that? Well, I should need almost nothing, right? I should almost any theory should be better than a bad theory, one that has no evidence supporting it, one that's just a religion.
Kind of aha moment didn't for me didn't happen, and of course I didn't even know about wave particle duality, and so I had done something that I had no reference to in terms.
Yeah, I haven't. You know, it's a reasonable thing to say. Gee, it's really bizarre that, you know, you can come up with this better model. I mean, at least their model is better than the existing one. It's not better than mine, but it's better than wave particle duality nonsense. But yeah, you can't get anybody to listen. So what's the point? What's the point of figuring out when you were so smart? Because no one's going to recognize you were so smart.
In terms of what science was trying to do or trying to understand. And so I just came up with the idea. And as I remember, I tried to get it across to you one time and didn't get anywhere. And a couple of weeks later, we were together, and I finally interrupted you and Bob Berger with this information because I wanted to get it across to you, and I hadn't been very successful until that evening.
So in conclusion?
So yeah, what's the lesson learned? You know, is that persuasion is this weird little, you know, it's mushy. What's going to get people to get it or grok it or understand it. And so what's the real obligation? To prove their theory wrong or to prove your theory right? You know, it's all very muddy water. And what we really need is what physics hasn't done, which is to do experiments. Again, there's so many simple photon experiments, right? They do a double slit. They've never put photographic paper on the sides to see how many photons go at high angles. Never done the experiment. They've never tried to get that pattern to go wider and wider and wider. You know, why? I mean, obviously you should have the photographic film, you know, as a round circle, equidistant from the slits. You know, all of those experiments haven't been done. And they would be very enlightening in terms of arguing that it's not about waves. Because the fact is, no photons go this way, none go this way, none go that way. It doesn't happen. And that would prove it's not a wave function. All right.
You are the only person in the last 400 years that had those two characteristics. And that's why...
It's not true, but okay, go ahead and say it, even though you know who I am. Go ahead and say it. I got kicked out of their little club because, you know, their club is full of religious kooks. And they're really belligerently stupid. See, he can't even make these arguments in his little, whatever it is, St. Jude Club. Whatever it is. I can't remember the name. John Burke Society, whatever the fuck it is. Anyway, they can't even talk about this stuff because all they care about is relativity for some reason. Every single video now is just relativity, relativity, relativity. And they're all, you know, they don't even get the obvious argument that all you need to do to prove there's no relativity, there's no time dilation, is just prove that the universe is full of little bits of energy and you can never escape that clock. There's the same little bits of energy hitting stuff 10 feet away from me that there is here. And if I go 10 billion light years away, the same amount of little shit is hitting me. I can't time dilate. I can't escape the universe's constant noise signal.
You came up with a solution for the wave particle duality. So congratulations. We'll put an applause there. All right, and you seem to agree with that, at least in part. So
so they'll probably be hanging me in effigy in the future when they find out what the real answer is. Because
so I don't even know what that is an implication to. They'll hang you because they find out the real answer. Well, your answer was irrelevant. They didn't even pay attention to it, so I don't see why they'd bother hanging you. And the existing answer is garbage, so they should be hanging all the other scientists. And the fact is, I'm right, so the fact is, you know, my people will be hanging. Whoever's going to get hung, they're going to get hung because my people did it. And the only thing I'm telling my people to do is piss on the grave, okay, of these cranks who want to dismiss these arguments without even paying any attention to them, without debunking them. Piss on their graves.
You pointed out this is like one answer. There may be a better answer, but
oh, brother. So why, you know? Well, there is a better answer. It's my answer. It's the same idea, though, that this is about stuff interacting with stuff. It isn't about nothings interacting with somethings. So obviously, as soon as physics starts talking about a virtual photon or bent space, yeah, you ought to just, okay, say forget it. All right, make it a something, and then you can play. But we're not going to play the nothing did something. Nothings can't do somethings.
go with what seems to work for now, and maybe at some point it fails.
Oh, well, whatever. I mean, just wishy-washy on top of the whole video. Just make the whole video irrelevant by just saying, oh, well, who cares, whatever, fine.
What's really, really interesting, and that's why you got to keep tuned to my dad and I's conversation, because this story is a long and fascinating one, is once we got...
It's not that fascinating, frankly. I think I've had my fill of the story, frankly. So, yeah, just make experimental arguments. Show me an experiment and explain how your theory explains the outcome of the experiment.
Once my dad came up with a solution for the wave-particle duality.
Yeah, it's not a complete solution, so it's really just a sol. S-O-L. It doesn't have the ocean part yet.
Things exploded, and we probably had the most fun in a year and a half that we've ever had.
So, yeah, I don't know. You know, none of this is fun. Yeah, frankly. It's hard work devising the model. And then once you devise the model, you have to explain it to imbeciles. And that's no fun at all.
Scientifically, yep. So stay tuned.
Whatever. The show. It's all about the show. Alright, so anyway, it's nice to see David's still doing okay, playing along. He's back making videos, so we'll see if any of them are worth watching, blah, 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 and such. 2. Happy 2 Day. Yeah. Just whatever. All these salutations that people bother with. Fuck you till dead. I think I'll stick to that one. Anyway. So enough of a video. And such and so forth and whatnot. I could draw a little bit. I could add a little value. So I think I'll do that. So I'll just close that. So a photon hitting a surface is the interesting part, right? So we know that surfaces are made, these are usually material surfaces that create this phenomenon. So you need something that has kind of a rigid arrangement. So you have electrons and protons kind of rigidly arranged. All the electrons essentially can feel each other. So they're sharing pressure. They have a hostile connection to each other, and they have an attraction to common protons. All right. So you have in a sense, a medium. And what you're basically going to do with what the photon's going to do is it's going to hit one electron, and when it hits that one electron, these other electrons are all going to move. Okay? So you've taken one electron, pushed it into the force field, you could argue, of all the other electrons, so all of them are going to feel the pressure increase. And then you're going to hit again, all right? So that was the first bit of the photon. The photon has these pieces. The first bit hit here. The next bit's going to hit, let's say, out here, right? And so this electron is moving this way already. And now you hit there again. So now all of these electrons are going to move with extra velocity because this electron already has a velocity. Now you're going to increase its velocity, right? So you hit an electron right behind it, let's say, and now you're going to push it even faster. So it was going 10 miles per hour here, it's going 25 miles an hour here, and then the third bit shows up and hits behind this one again. So the polarization could go this way, the polarization could go that way, it could go any direction. It just happens that this is the direction that the polarization of the light was in. So this will be the direction of the electron achieving a high enough velocity to actually knock its neighbor electron out of its position and take its place, and then the next one and the next one. That's the electrical cascade. So the electrical cascade is what you're looking to create. That's when you have something we call a photon. Is when you make that electrical thing happen. And if you don't make that electrical thing happen, then the thing just remains a little vibrating piece of crap on your surface. It doesn't mean anything. It needs to make the electrical thing happen to be something we can collect as energy. All right. And then obviously if you use higher enough frequency light, you'll eject the electron. You'll give enough energy to bounce it right off the surface. But that's the basic idea, that the photon doesn't have a character until it actually hits the surface. The surface will decide what the reaction is going to be. The photon, is just bits hitting in a sequence, and it has to hit a surface that can be receptive to that happening. So usually in the form of a solid, if you want to collect it as electricity. All right, enough said. So till the next time, and such and so forth and whatnot. I'll label it some kind of draft video. It's not an important video, but whatever. It's a video to selective people who might possibly be interested. Maybe. Anyway, I did update the website, so I guess so somebody who listened all the way through this, okay, yeah, you'll get the bonus of that. Let's see, so I have to, where is the page? This looks like it'll work. I go here, and so I redid the the debate physics website. Yeah, so it's now, let me just find it. Okay, that should be it. Turn that on, and there it is. Yeah, I just got to resize it. All right. So it's just going to be a list of, I'm going to annotate the videos I produce and have some kind of statement about them as I produce them, something like that. And so it's going to have a little bit more written information, and there'll also be videos that aren't public, so unlisted videos. So I did do a response video to Michael Fulwell, and so it'll be on the debate physics website. So videos that are sort of a waste of time, yeah, they'll probably be on the website if you want to see them. You'll need to go there to see the link that's you won't see because it's not a listed video. So there'll be a few of those now and then. I'll call them unlisted, just so you know they're videos that aren't on the regular channel, not available in a YouTube search and all of that kind of crap. But anyway, so this video will be on this list soon and such. So that's the debatephysics.com website. Hopefully that address will work. I mean, it's all this security crap is just so annoying. I mean, they break your website, because you won't pay to encrypt a website that doesn't need to be encrypted. There's no data on this website that needs encryption. There's no security risks anywhere. It's just so annoying what the internet's become. So anyway, enough said. So till the next time, and such and so forth and whatnot. I mean, I'm trying to make it a little more interactive. So eventually I'll try to incorporate comments into this and some other things if somebody can make a rational comment, which is very rare. And I'll list all of the cranks, so down here will be a listing of all the crank conversations where somebody claims to have debunked me or done something, these fake frauds and phonies. Wikipedia, the whole argument with Wikipedia. So I'll create links to all of that crap, that just demonstrates they don't want to hear the truth. That's all it demonstrates. The Inquisition. And that's all it is. Science is a religion, and it's behaving like a religion. Alright, till the next time, and such and so forth and whatnot.